this is technically section 3.3. Evaluating with inverses. So we're evaluating with inverses, simply saying that if we have exponential, remember to change exponential, to simplify an exponential, you can change it into a log. Or if you have a log, you can change it into exponential. They go back and forth. If we have something that is just e, we can change, or its inverse, we can change that into a natural log. And if I have something in a natural log, we can change it into e. They go back and forth, right? Yeah. Okay, so let's start with our exponential. To remind you about exponential, we usually wrote it as y equals ab to the x. Well, we're going to say a is 1, so we're not going to worry about a. So we have y equals b to the x. And to rewrite that in log form, that is log base b of y equals x. All right, your base to your exponent is the base to your log. Your x is your exponent, which is equal to your x over here, right? Okay, so we can also take it from this form and rewrite it in this form to find something, correct? Okay, so that's where we're going to start. Example number 1. Evaluate without the calculator. So if we have something as simple as, how about log base 3 of 3, yeah, we'll start there. Log base 3 to the third. That's one of our rules, but one of the things we did before is we went ahead and set this equal to x, if you recall, and then we rewrote it in exponential form. So we can take our base, which is 3, raised to the exponent of x equals what's written behind our log, which is 3. So it's just 1. X equals 1. And we knew this was 1 simply because it was one of our rules, right? When the base and what's behind the base are the same, it equals 1. Let's do another one, a little bit harder. Let's say I have the log base 2 of 16. And I want to evaluate that one. I'm going to set it equal to x. Then we're going to rewrite it in exponential form. Now it's important to practice this exponential form because when we start solving equations, you can't use your calculator to do that. You've got to be able to switch them. So we're going to start with our base, which is 2, raised to the x or the exponent equals 16. So we have to get the bases the same. Exactly. This is review, right? 16 is 2 to what power? 2 to the 4th power. So now this is technically a 1-to-1 function, and we can set our exponents equal to each other. X equals 4. You guys remember doing this, don't you? Okay, good deal. All right, let's do one more before I move on then. Let's make it harder. How about if I have log 1 over the square root of 1,000. All right, so first of all, tell me about a square root. What is the exponent that means square root? Perfect. Okay, so I'm going to change this into log of 1 over 1,000 to the 1/2. All right, what else can I do to this? Yeah, I like that idea. So I agree. We're going to change this to log. To bring this to the top, that exponent becomes negative. So you have 1,000 to the negative 1/2. Now if we're going to go ahead and evaluate this, I'm going to set it equal to x. So I'd like to have it all in one level when I set it equal to x. Then when there's no base written there, what's the number? Awesome. So 10 to the x equals 1,000 to the negative 1/2. What do you guys want to do now? Get it to 10. So this is actually 10 to the what? Okay. So I'm going to write it this way so you can see each of the steps. 1,000 is 10 to the third, still raised to the negative 1/2. When you have an exponent raised to an exponent, we multiply them. Exactly. So this is 10 to the x equals 10 to the negative 3/2. So what does x equal? X equals negative 3/2. Now, obviously, I went through every single step. You don't have to do all of those steps, but I wanted to make sure they were all there for you, right? Okay. Let's talk about natural log and e. What do you think? All right. So let's go to example number 2. Maybe. There we go. Example number 2. Again, I want you to evaluate. And maybe you get something as wonderful as the natural log of e to the negative 4. We'll start easy. We talked before about how natural log and e are opposite each other, right? So they actually cancel. If I just have natural log e, this equals 1. So it's just negative 4, yes. So technically, we can say that this exponent is going out in front. So I have negative 4, the natural log of e. And if this equals 1, this equals negative 4. Okay? Let's do another one. How about this one? What if I had the natural log of 1 over the square root of e to the 7th? What do you guys think this one's going to be? So we need to get the natural log and e next to each other, right? So we need to get that square root e to the 7 all to the top somehow. 7 over 2, I agree with that. So the natural log of 1 over e to the 7 over 2. And then I agree we're going to move this to the top. That becomes a negative exponent. So we have the natural log of e to the negative 7/2. So what does this equal? Perfect. I've always found natural log and e actually easier than log and exponential. So any questions there? All right, so let's take it just a little bit harder. This is all you're doing for 1 through 17. Okay? Example number 4. 3. Sorry, example number 3. It was a long weekend for me too. Example number 3. I again want you to evaluate without the calculator. And what if we have 7 to the log base 7 of 5? All right, so this is an exponential form, right? When we have something in exponential form, we set that equal to y, right? Y equals ab to the x, correct? Okay, so technically I'm going to say this is y. So then I'm going to rewrite this exponential in log form. Okay? In log form, I have log. Base. The base to the exponent is the base of my log of y equals the exponent, log base 7 of 5. Correct. So y equals 5. Because that becomes a 1-to-1 function, right? It looked bad, didn't it? But it really isn't. Go ahead. This right here is actually the whole exponent. Okay? So that's why when I set it equal to the exponent, it's that whole thing. All right, let's try another one. Let's say I have 10 log. Actually, no. Let me make that an exponent log. Sorry, my bad. As an exponent, let's say log 14. So this is an exponential form, so we're going to set it equal to y. And now let's rewrite this. We're going to say log 10 of y equals log 14. So y equals 14. I agree. So again, they look way worse than they are, right? Okay. All right, that's all you're doing through 23. You ready to move on to the next section? Yeah. Right, yep, exactly. All right, example number 4. I want you to solve by changing to exponential. So maybe you're given something as awesome as log x equals 4. In order to figure out what x is, we have to change this into exponential. Got to get rid of the log and change it. So right now, again, when there's no base written there, what is it? So we're going to have our base of 10 raised to our exponent of 4 equals x. So 10 to the 4th power. 10,000, right? Equals x. Yes. A 1 and 4 zeros. I agree. All right, let's try another one. Oh. All right, let's say I have the log. Whoa, that doesn't look good. Let's try that again. We have the log. The base 3 of x equals 2. All right, to solve for x, what do we have to do? Yes, change it into exponential. So 3 to the 2 equals x. So x equals 9, absolutely. All right, any questions on those? The only solving ones you have today are really that simple and that straightforward. Okay, so you only have a couple of them, but it's to remind you, all right? Questions at all? Okay, so then we got to get into, what we really have left is 37 through 51. Okay? No, good try though. So the last part is about graphing, and I want to talk about graphing. Again, when we graph logs or natural log, you're going to throw it in your calculator. I know you are. But I know you are, but the point is we need to be able to describe the transformations happening, correct? So here is example number 5. All right, so if I were to give you y equals 3 log of x minus 2 plus 1. Okay, and we're going to describe the transformation to begin with. First of all, what does that 3 in front do? Good, stretch a 3. How about the x minus 2? Right, 2. And up 1, very good. All right, so what I want you to do is realize what exactly is happening. So on a log function, the graph always goes through, the original log function, always goes through the point 1, 0, and it approaches the y-axis but never crosses it. So it looks like a curve like that. Okay? It doesn't cross it until, of course, it translates one way or the other, because you can't have the log of a negative number, right? We've talked about that before. Okay, so if I were to take this, I'm going to stretch it, which means this is going to go up higher. I'm going to move to the right 2 and up 1. So if I were to throw it in my graphing calculator, it's going to look like it's gone over here and stretched up higher, right? Okay, so let's do one more, describe it, and we'll see if it matches what's in our calculator. Change it up just a touch. Let's say we have y equals. That's the one that's translated, yeah, the stretched right 2 and up 1. Okay, let's say I have y equals negative natural log 3 minus x plus 4. All right. Okay, so this first negative in front is a flip of what? Flip over x. Then in here, what's happening next? It's going to flip over y. And then which way? If you were to take what's inside there and set it equal to 0, if I have 3 minus x equals 0, that means x equals 3. So this is going right 3 and up 4. All right. Now I bet you guys aren't going to be shocked to see that the natural log graph is the same. The only difference is it kind of like flattens out a little bit sooner. That's it. So if we were first to flip this over x, it's going to come down here, right? And then if we were to flip it over y, it's going to be over here. And then we're going to go to the right 3 and up 4. So if you were to throw this in your graphing calculator, hopefully it would look something like this. Yes. Well, I'm looking for you to describe it. I want you to put in your calculator just to make sure you described it correctly. Okay? No, I'm okay if you don't put the graph on the paper. It says to graph it, but if you describe it to me, I know that you can throw it in your graphic calculator. We all should be able to handle that, right? Go fast. I'm going to pretend you gave me your planner and everything. Just go. All right. Any questions at all? That's all you had to do for that last section is describe the transformation. Throw it in your graphing calculator just to make sure you're right. Okay? Okay. All right.